Welcome to Easy Math TV. We're going to continue our discussion of average rate of change. This time we're going to talk about how a quantity changes per person over time, and in the same context as before with the natural gas consumption in the United States between 1997 and 2022. So the question we're asking is this: on average, how much of an increase or decrease in natural gas consumption has occurred per person per year in the United States between 1997 and 2022? So we're going to need one additional piece of information. Um, in our previous video, you actually saw we talked about the years. So here's our delta x and our x over here in columns B and C. So our x values are still going to be the years, but this time our y values, the thing that we're actually tracking as far as like how much it has changed over time, is something we call consumption per person or per capita consumption. So that's going to be in column F over here, and those are our y values. So, it's always a good idea to just identify what is your delta x and what is your delta y. So time is going to be our delta x, and our delta y is going to be consumption per person. Okay, so I needed to know the population, so I looked that up, and I was told that the population in 1997 was approximately 272.9 million. So what I did was I took 272.9 and multiplied by 10 to the 6th power to get my 272 million. You didn't have to do that. You could have just typed in 272 comma 900,000, and be done with it. But I just wanted to show you that you could actually take, if a number is given to you in millions and it says it's 333 million, you can just multiply by 10 to the 6th, and that will also accomplish the same thing. So in cell D4, we have 333 times 10 to the 6th. That's the approximate population in the United States in 2022. So again, in the spreadsheet, I've tried to be consistent here by keeping anything that's in row 3 is going to be information from 1997, and anything that's in row 4 is going to be relevant information for 2022. Okay. Then again, just take a look at our column E real quick. Those are the numbers from the table that we got in the Energy Information Agency. And I actually didn't round those. I actually took the actual number from the table, 207,82693, and that number again is in millions, so I multiplied by 10 to the 6th there. And notice I use the equal sign because you have to do that whenever you're performing a calculation. So those are pretty big numbers, but they're going to be divided by the population. So we're going to get more manageable numbers over here in column F anyway. To calculate the consumption per person, then we have to take the consumption itself and divide by the population. So that's equals E3 divided by D3, and then down here in row 4 equals E4 divided by D4. So that gives us the natural gas consumption per person as a per person thing. So there was no guarantee that that number was going to increase. I had no idea what was going to happen to that number, but it did in fact go up. It went from 76,000, and remember that's over a period of 25 years, up to 87,667. So the consumption per person did go up. Then over here in column G, we just subtract, so we get equals F4 minus F3 because that's our delta Y. And once we have our delta X and our delta Y, we go over here in column H and we divide those two to get our average rate of change. Remember, average rate of change is always going to be delta y divided by delta x. And that equals G4 divided by C4. So, again, the hard part of these problems is determining what the x and the y variables really actually represent. And it comes down to really just asking yourself, what am I comparing here? I want to know the natural gas consumption per person, and then I want to know how much that changed over time. So that kind of tells you, when you say that out loud to yourself, you can actually hear yourself explaining what the y and the x variables are. Okay, so our natural gas consumption per year has gone up by 460 cubic feet per person. So I don't know if that's something to be alarmed about, but maybe it just means that our consumption of other types of fuels has gone down. I don't know. Anyway, if you like these videos, like, subscribe, comment down below. I need that kind of support so that I can start to produce better content. Thank you.